So for this one, okay, basically determining your empirical formula, what did everything have to get converted into? Moles. Moles, yep. So we assume 100 gram sample, which just means for us that we are going to, yep, we're just going to take those percents. We're going to chop off the percent part and just call it grams. So that was for carbon, so we're just going to divide it by its molar mass. Okay, to get 4.33. And then 13.14 grams of hydrogen divided by its molar mass. And we would have gotten around, so my numbers might be off by like a decimal, but 13.404-ish. And then 34.75 grams divided by 15.999 to give us, or the 16 is fine, to give us 2.17. So now that I was in moles, okay, now we are trying to find that ratio, how they relate to each other. So you divide by the smallest, so 2.17, 2.17, 2.17, and we would have found that this one would be approximately 2, approximately 6, and 1. So that tells me the empirical formula was for sure, not sure what I was writing there, sorry. Empirical formula was C2H6O. Okay? All right, so that was as much as I had asked on the test for sure. But then I could have turned around and given you this second part. I think I gave it to you on a totally separate question. And so what we do when we're trying to figure out molecular formula is we would say molecular formula mass divided by empirical formula mass. And so we would have had the 184.1 on top. You would have added together 2 carbons, 6 hydrogens, and 1 oxygen. So 2 carbons would be about 24 plus 6 is about 30 plus oxygen, which is about 16, so 46-ish. Okay, so 46 grams. So if I did that, 184 divided by 46, what would it be? 4-ish, okay. So once we have that, now we would take that and multiply it by the subscripts to get C8H24O4. And that would have been the answer to the second part. Okay? So some of us on the test, we got to this part, and that was the answer that we wrote down, and that wasn't where you could stop. You had to apply it now and multiply it by the subscripts. Okay? All right. Cool. So once you're flipped over to the back, I'll just shrink this one to get them out of the way. You can title this as Combustion Analysis. Okay, and so you guys should have your gram to gram homework page. On the back of it are 3 homework problems of combustion. You have to do 2 out of the 3, and just so you know, the first one is super short. It'll be shorter than what we do in our notes. It's an easier one, and then you just have to pick one of the other 2 to complete. Okay, that worksheet, I'm hoping by tomorrow, but we can push that to Wednesday if we need to. Okay, so the other 2 were due on Friday, so make sure those got turned in. So for combustion analysis, basically, if we were to look at a combustion reaction, just like what that generally looks like every single time, we know that we have some sort of a fuel that combusts in oxygen. So usually we have to strike it or set it on fire, okay, to get it going. And that's always going to yield carbon dioxide and water, and we rely on that guarantee right there. Okay, so for combustion analysis, basically our goal is to find the empirical formula, what we just did in our note or in our warm-up, find the empirical formula of mystery fuel. Okay, and really what we actually use it for is more finding the molecular formula, but for pre-AP, I usually just get you guys to the empirical formula and then AP, or you throw in that other part. But it's really easy. It's just like the warm-up. If I give you the molar mass, you can figure it out. Okay? So ultimately, that's really what we're doing. But for the notes, we're going to be talking about just the empirical formula, so getting us that far. Okay? So when we are doing that, we have to assume two things. Okay? And we really rely on these two things. We assume, due to law of conservation of mass, that all of this carbon becomes what? Carbon dioxide, right? All of this carbon has to turn into the carbon dioxide, right? Due to law of conservation of mass. So we're talking about a closed system here. It has to go somewhere. It turns into carbon dioxide. It rearranges, right? So assume all carbon goes to carbon dioxide, and all hydrogen is going to turn into what?
Water.
Water, yep. Okay, and so usually the way these things, if you go look it up, there's some pictures out there. I didn't pull any to show you in the lecture, but there's ways that we collect the carbon dioxide and the water, and we basically work backwards. So we have those two products that are created, and now we can figure out what that mystery fuel was. Okay, so we can figure out the empirical formula of it. So that's what we're going to be doing. We're going to be working from carbon dioxide and water to the empirical formula of that CHO thing. Okay, and if you want to see what some of the questions look like, you might have the gram to gram worksheet flipped over to the back, so you can actually read what the questions actually sound like. Okay, otherwise you can look at it after we're done. All right, so I'm just gonna move that up here. Okay, so starting us off, okay, the easiest way to learn these is to just dive into a practice problem. So our practice problem, we're gonna have a 17.471 gram sample and I'm not going to have you guys write, but you can just say that consists of carbon, hydrogen, and oxygen, so it consists of all three. Okay, combusts and forms. And I'm going to give you two values for our water and then our carbon dioxide. And forms 10.477 grams of water and 25.612 grams of carbon dioxide. What is the empirical formula? Okay? Yes.
So problem number one of the back of the gram to gram version.
Yes.
Is there a typo because it only tells you the weight of the compound and
Okay. So we're going to use that 10.477 grams. In the empirical formula warm-up that you guys just had, what did everything need to get converted into? Moles, right? Moles. So we're going to get everything into moles, and then we are going to end up converting them also to grams, but let's get to moles of each of these things. So we're going to have the 10.477, we'll start there, grams of water. Okay. Words come down to the right. We're converting into moles, so we know that that's just the molar mass down here. Okay, so 18.02 grams of water is 1 mole. Okay, but is moles of water going to be useful to me if we're trying to figure out an empirical formula? So something that just has carbon, hydrogen, and oxygen. Is the water moles actually useful for dividing by the smallest and all that stuff? No, we need it to be hydrogen, right? So we're going to take 1 mole of hydrogen, or water. And this step you can always rely on for water, okay? 1 mole of water, and we're going to convert it into moles of hydrogen. How do you think we're going to do that? This is kind of like the mole bridge step, except we're not doing the balanced equation, right? Because we can't balance that. We're looking at the formula itself. Yeah?
What does it need to be hydrogen?
Because we're trying to figure out what the C... So your goal is figuring out X, Y, Z from that original formula.
Oh, okay.
Okay? All right, so how many hydrogens are in a water? 2. So it's a 1-to-2 ratio. Okay? You can do that. You can use your subscripts for the mole bridge. All right, so when you type that into your calculator, we should be getting about 1.163. I'm just going to be honest with you. I'm kind of copying my notes. My sig figs are not, there's no rule to any of my sig figs because in the end we're going to end up rounding everything, so I'm kind of not really caring too much about the sig figs. So I encourage you to not stress out over sig figs, okay? All right, so you would get 1.163. If you want to type that in to make sure you get that, that's cool. And just kind of put a little cloud around that number because we're going to need that at the very, very end. It's in moles. Okay? Okay. So, we're going to need that moles. But we are also going to need, yeah, we'll come back to it. All right, let's do the carbon dioxide now. So, 25... We have 25.612 grams of carbon dioxide. Okay, bring words down to the right. Again, this is molar mass down here, so 44.01 is 1 carbon and 2 oxygens added together to convert into 1 mole of carbon dioxide. Again, carbon dioxide is not going to be useful to us, so we're going to bring moles down to the right. 1 carbon dioxide has how many carbons? Only 1. So this one is a 1-to-1 ratio. So really, you don't need to have that step, mathematically speaking, but you do need to show it because that you are still relating it to that mole ratio. Okay? All right. So when we type that one into the calculator, you should be getting 0.582 moles of carbon. And again, put a little cloud around that one because we're going to need that. Okay? So the first thing that we did was we found moles of hydrogen and moles of carbon. Okay? Or moles of whatever is given to us in the problem. Okay? You'll see what he meant earlier by number 1 on the homework. Okay. So I'm just going to squeeze this, put this over here. There we go. All right. So now that I have my moles of hydrogen, I have moles of carbon. What's our piece that's missing? Probably the oxygen. Do you guys see that? Right? But I did give you a piece of information about the sample size. Okay? So I gave you this little piece of information right there. Right? So we have to, so what we're going to try to get ourselves to is we need to know that total sample is going to be equal to carbon plus hydrogen plus oxygen. Do you see that? So on a question where it doesn't have the oxygen, where it says it's just carbon and hydrogen, that's all that you're actually doing. So you can figure it out from there. So those values are all in what, though? What is the total given to us in? Grams, right? So we have our 17.471 given to us in the problem is equal to, do I have grams of carbon? No. We have to get these moles into grams. So I'm just going to add an extra step, okay? And if you're running out of room, what's the quick way to do it? instead of sitting there writing and bringing moles down to the right? Is it multiplying by molar mass or is it dividing by molar mass? Multiply, right? So you're just going to say times the molar mass, which is 1.01 grams, and this 0.582, we're going to multiply by 12.01 grams. Okay? So once we get those two answers, so again, just kind of copy it down with me. You'll have an opportunity to do one on your own. Okay? We would get 1.17 grams of hydrogen, and we would get 6.99 grams of carbon. So now those pieces can come down here into our big addition problem. And we're solving for the blank because we're solving for oxygen. So now that I have everybody in grams, what did we find oxygen to be? How do we solve for this little blank right here? Algebra or, yeah? Rearranging it, right? Because we're solving for x, yeah? So is it subtraction, division, multiplication? What is it?
Subtraction.
Subtraction, good. So take that 17.471, subtract the carbon, subtract the hydrogen, whatever is left over has to be oxygen. So you should be getting 9.31. Okay? So now that I know what oxygen is, what do you think we're going to want to do to it? This is grams of oxygen. We got to convert it to moles. Why? Because we have, so we can do empirical formula. Exactly. And we already have the other two ready to go. So now let's get oxygen ready to go. So I'm just going to kind of write it off to the side. What is that kind of math? Are we multiplying by molar mass or dividing it now? We're dividing it. So we would get 0.582 again. Sorry, guys. 0.582. Okay? So we have 0.582, and this is moles of oxygen. So now you have three things that you've kind of pointed out in your notes that are important. Those three things are what we're going to use to finish out and find our empirical formula. So now that we have all of three of those moles, 1.163 moles H, 0.582 moles of carbon, 0.582 moles of oxygen, we need to do our empirical formula. So we're going to divide them all by the smallest. You should not have to type any of these in because you should be able to look at that and do them, I would say. Okay, so what is the 1.163 approximately? It'll be about 2-ish, and then these guys are 1 and 1. And then whenever you write these, you should always follow this format, the C, H, and then O. So we're going to go C, has a subscript of a 1, we don't write it, H2O, and that is your empirical formula. And then, just like in the warm-up, that second part to the question, you could figure out molecular if I gave you a molar mass. And that's it. I say that's it, and you probably have your page completely filled out. But so we'll try one together right now. I'm sorry, I'll let you guys try it, and then we'll kind of check it, and then you guys should be good to go.